We are up to section 4.6, which is entitled Isosceles, Equilateral, and Right Triangles. So we're going to start by talking about isosceles and equilateral triangles. The first theorem here is a very useful one. It's called the base angles theorem. If you have a triangle in which two sides are congruent, the base angles theorem tells you that the angles opposite those sides are also congruent. If two sides of a triangle are congruent, then the angles opposite them are congruent. That's theorem 4.6. We're on page 236. The converse of the base angles theorem says, if you have a triangle in which two angles are congruent, then the opposite sides are going to be congruent. If two angles of a triangle are congruent, then the sides opposite them are congruent. So you have the base angles theorem, which is BAT, and you have the base angles theorem converse, which is BAT with a C. Very useful. There is a corollary to theorem 4.6, which is the base angles theorem, and that says if a triangle is equilateral, then it's equiangular. Now you can use the base angles theorem to establish this. If it's equilateral, then these two angles are congruent because these two sides are congruent. These two angles are congruent because these two sides are congruent. So I'll mark this one, and now of course we have all three angles congruent. And by the way, of course you already know this, in an equilateral triangle, all the angles are 60 degrees. The corollary to theorem 4.7 is if a triangle is equiangular, pardon me, then it's equilateral. So if all the angles are the same, then the triangle must be an equilateral triangle with all the sides being the same. Now, we have studied angle, side, angle, 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 side, angle, side, and side, side, side. Those are 4 of the 5 ways of proving triangles congruent. The 5th way is hypotenuse leg. And this applies only to right triangles. So let's draw a right triangle, and you will recall that the legs are here and here, surrounding the right angle, and the hypotenuse is opposite the right angle. This theorem says that if you have two right triangles, and you are trying to establish them as congruent, let's call this A, B, C, and D, E, F, and they are both right triangles. If you know that the hypotenuse of one is congruent to the hypotenuse of the other, and you know that one of the legs of the two triangles, one leg is congruent, then you have enough to prove the two triangles congruent, assuming and only if they are right triangles. Now, it didn't matter which leg I picked. I could have picked that one, or I could have picked this one. All you need is a right triangle, two right triangles, and the hypotenuse and one leg being congruent. You will notice that if you were to name this as one of the 3-letter names, like angle, side, 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 or angle, angle, side, this would actually be angle, side, side. But as we've discussed before, angle, side, side is not a congruence. And you will find out more about that when we study trigonometry. In the meantime, this one is hypotenuse leg, or HL. So just to list and summarize the ones that we have now. We had angle, side, side, angle, side, angle, angle, side, 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 and now we have HL. So we have 5 different ways of proving triangles congruent. You will be using all of them at one time or another. Let's take a quick look at a proof here, just to make sure that this is all making sense from a proof perspective. Let's see. Let me see which one of these we want to do. Let's do this one. It's on page 241, and it's proof problem number 33. So, take those away, we'll take these away, And we'll make this drawing here. All right. Is that right? Yes. Well, more or less. It doesn't look great, but so let's try to fix that a little bit. All right. It's hard to fix a drawing once you draw it. All right. Now, we have, let's see, B, C, D, and E and F. And we're trying to prove these two triangles congruent. Now, you're given information over here is, this is statements and reasons. Number one, first piece of given information, D is the midpoint of CE. D is midpoint of CE. And that's given. All right. Number two, no, more given. So we're going to be able to establish this is congruent to this. That's going to be the leg of our triangle, triangles. Now, BCD and FED are right angles. Angle BCD and angle, I think I said BCD and FED. FED are right angles. That's given. And BD is congruent to FD. FD, and that's all given information. So let's see, BD to FD, so this is congruent to this. Now we can establish, that's the hypotenuse. Remember, we have right angles, so these are going to be, so we can establish that they're right triangles. So let's say CBD, triangle CBD, and triangle EFD are right triangles. And that would be definition of right triangle because they have right, each has a right angle. Definition of right triangle. And we can also state that angle C is congruent to angle E, or BCD is congruent to FED. Angle BCD congruent to angle FED. Why? Because all right angles are congruent. That's the right angle congruence theorem. So right angle congruence theorem. All right. So now we have this congruent to this. We have that congruent to that. We haven't yet dealt with the midpoint. If D is the midpoint of CE, then CD is congruent to DE, and that would be definition of midpoint. So now we have this to this. Okay, we're trying to prove the two triangles congruent, and look what we have. We have the hypotenuse and a leg congruent to hypotenuse and leg of right triangles. Therefore, we can use HL, and we are trying to prove in this case that BCD is congruent to FED. So BCD to FED triangle. So here we go, triangle BCD congruent to triangle FED. And the reason for that is HL. All right. So there's how the hypotenuse leg proofs are going to work. Let me just see if there are any other types of problems here that you might want to take a look at. Yes, I believe there are. Problem 23 on page 240, I would like to go over before we close this video. So this is not a proof. I'm going to take this away, and I'm going to try to draw this thing. So it's a triangle that looks like this. Start with that. And then we have another triangle out here, like this. Okay, now you're given some information here. You're given X, this is angle X degrees, this is Y degrees. And this is all marked, this is congruent to this, is congruent to this, and this is congruent to this, and you are asked to solve for X and Y. All right, for one thing, we know this is an equilateral triangle, therefore all the angles must be 60 degrees. All three sides are congruent, so all three angles are congruent. We also know that angle x, if this side is congruent to this side, then this angle is congruent to this angle, so we have two x's. Now let's see what else we have here. We are trying to find x and y. There's one more piece of information that I didn't give you yet, and it's a very important one. Let me move this 60 down here. This is a right angle. Critical piece of information, because if that's 90 and that piece of it is 60, that piece must be 30. So now we know x is 30 and 30, and those two total 60, so this one must be 120. So x equals 30, y equals 120. All right, I hope you're catching on here. Let's look at one more triangle, one more problem here. And that is, if I can draw this, it is a, let's see, we have a triangle here. Looks like this. Oops. And then we have this going off this way, and then coming back down. Let's see, that goes way out there, and then comes back down here. Let's make that a little straighter. And this problem, by the way, is number 25 on page 240. Now, you're given some information. This is congruent to this. You know what? I got to make this look a little bit better, because actually that should be coming up through the middle here. According to the drawing, that's going to be a little bit better, and then that's there. All right, this is a right angle. We are told that. You are also told that that's congruent to that, and you are told this is 60 here, whoops, 60 degrees, 60, and you are told that this is y degrees, and you are told this is x degrees. Now, you're also told this is congruent here. So all three of these are congruent. We are trying to solve for x and y. Well, if these two sides are congruent, then these two angles, forget about this for a moment. Base angles theorem says these two angles must be congruent. So now we know x is 60. All right? You also know then, let's see, what else do we know? We know that these two sides are congruent, therefore these two angles are congruent, so that must be y. Now, we know this is 90 right here. So let's see if we can solve. This was x over here at 60. Now we have 90 plus 60 is 150. So y, to fill out the 180 in this triangle, must be 30. So we have x equals 60 and y equals 30. All right. This is probably sufficient for the moment for section 4.6. And the next two sections are on, the next one section, excuse me, is on triangles in a coordinate plane, and that will conclude chapter 4. But we have some proofs to do in between, so I will see you next time. Thank you very much.